Hello, everyone. Thank you so much for joining our today's session. So, this is called Intro to Vectors. It's a very beginner friendly and an intermediate friendly session that is going to facilitate people to learn more about vectors and maybe how to implement them into your LLM app or maybe into your current structure. So, we have Akmal on board, who is a very regular speaker at our webinars. So, welcome, Akmal, and thanks everyone for joining. And my introduction, my name is Yukti Dwivedi, and I will be your moderator today. One of my main jobs here at SingleStore is to organize weekly AI webinars. We organize maybe two, three webinars per week. So we demonstrate different data and AI use cases, new tools and technologies. And we also post about our upcoming webinars every week. So if any of these topics that is there on your screen as well, if anything's interesting to you, feel free to connect with me to stay on top of the loop. I'll also like to hear your ideas or feedbacks on sessions that you would like to see in future sessions. So feel free to connect with me on LinkedIn and drop a message. So speaking of future sessions, as you can see on your screen, we've got multiple informative new webinar sessions that are coming up. On September 13th, back on popular demand, we have LLMs in fraud detection. So the QR code is there on your screen, and I will be putting everything in the chat as well. And on 17th of September, on 20th September, we have how to use SingleStore for auto scaling. And we have more sessions coming up. So you will be able to see them on our landing pages. So if any of these topics are interesting to you, RSVP right now, and I hope to see you all there. Coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to try to answer 100% of the audience questions, even if that means following up with folks afterwards via email. But no worries, just ask away your question because we have to answer all the questions live. And just stay tuned for like your turn to come. Just make sure that you have logged into Zoom with your actual name and email address because we don't take up any anonymous questions. So moving forward, I'd like to announce today's raffle. So if we want you all to have a dynamic experience during this webinar, to feel free to try out SingleStore notebooks. Anyone who tries it today and loads in data, I will be putting the links in the chat again. With Akmal's notebook as well to facilitate you better with this. So you will be entered for a chance to either win branded new AirPods or Meta's new Ray-Ban LLM smart glasses. It's absolutely the winner's choice. Simply click the link that's present on your screen or scan the QR code. This will take you to the landing page and log in. Akmal is going to tell you about how to make an account on the free shared tier and just take some minutes. So that way you will make the most out of this session. So obviously your time is really precious, and uh, let me announce today's speakers. So we have Akmal joining us. He's a senior technical evangelist here at SingleStore and has done amazing sessions and has been a phenomenal asset here in terms of putting out content, developing use cases for companies. So Akmal, please take it away. We are really happy to have you.
Great. Well, thank you very much for that introduction, Yukti, and thank you all very much for joining. And so, as I always do at this time, just check my clock, and it's still 6 p.m., which it tends to be, unless it's a time change, which I think in the UK we get it at end of October. So currently it's fine. So as Yukti mentioned, this session is intro to vectors. And actually, when I was doing the research, preparing the material for this, there's actually so much to cover. And I thought to myself, well, we only have an hour. Plus, I want to show you some demos. And Yukti will post the link to the notebook that I'll be using today. So just please check the chat for that, okay? And what it occurred to me was that what we can do is make this a kind of a multi-part series. So today we do very much an introduction to vectors, cover some of the basics, and then perhaps the next one we can look at indexing techniques, for example. And then in the third one, we can do like fine tuning and benchmarks and testing and looking at indexes in detail, perhaps looking at some large scale data as well, which takes a bit of time to prepare. For those of you who are regulars, you know that I try not to load up enormous quantities of data simply because it takes too much time and effort to do so. But I think as those who may have attended Eric Hansen's webinar just the other day, I mean, Eric had like billions of data points in his database. And I think it took him a little bit of time to get to that point. I don't think we'll get quite that large, but certainly we can scale up to a larger size so that we can test these indexes at at scale, at the sort of kind of real world type problems that you may have. But anyway, thank you again for joining, and keep the questions coming. Okay, so as Yukti said, we won't take any anonymous questions, although actually we do answer them sometimes. Okay, I think it just depends on how many questions we have, but you're free to ask them, and I'll try and leave some time at the end there to assist you with that. Okay, so just before we get started, so by all means, take the links that Yukti is posting, okay? So one of them will be for a cloud trial, singlestore.com/cloud-trial, okay? So if you have not created an account already, please do so. That will benefit you, okay? Because you'll be able to load in the notebook and test it out. Plus, I can show you a few other things as well in this environment, which will be very helpful to you. So beyond what I'm just sharing with you today, there's a couple of other notebooks that you can access within this environment as well, which are somewhat shorter than mine, but again, give you a different perspective on vectors and indexing and so on. And so if you do sign up, literally, it's like a minute of your time. Even now, if you create a free account, what you'll find is that when you log in, it'll look something like this. And what they do very generously is even create the starter workspace for you. There was a time when you had to create this yourself. Now, when you log in, it's there already for you. So it will run on the AWS platform. You'll have a database created for you already as well. And you're all set to go. Basically, there's no time kind of lost, no time wasted in this environment. And for the notebook that Yukti will share, which is on my GitHub repo, if you go to the left-hand side here, you'll see there's something here called Data Studio. Okay, let me just highlight that for you, okay? So if you select that, obviously this is a kind of a copy of what I have there, but what you'll see on this extreme left, there is this kind of icon here, okay? And then just below here on the right-hand side, you can see this big purple button with new notebook. And if you actually click that, it's a pull down. So you get a couple of options. You can create a brand new notebook if you want, or you can import from file. And that's the option you want, okay? So import from file, and that will load it in. And then given that if you're creating a new account, you've already got the resources, excuse me, up and running, there is no need to spend time doing anything further. Basically, you just need to ensure that you're connected and you're all set to go. Okay, so if you want to take care of that in the next minute or two, meantime, I'll just present some slides. This deck originally started off very large, and I've hidden most of the slides because I suddenly realized that I'd overproduced. But anyway, like I said, we can split this up into multiple parts and then gradually build up the depth that we're going to cover. So briefly then, quickly about SingleStore, the company. So started life way back in 2011, formerly known as MemSQL. You may have come across the product and the company, both called that. Subsequently changed the name to SingleStore because we didn't just do in-memory OLTP anymore, but we added column store and OLAP capabilities some years ago. So it didn't make sense to call it MemSQL anymore. Vector support has been there for quite some time. Okay, I think it was a financial customer that originally requested it, and SingleStore has had this capability baked into the product for some time. So it's not something we just added because everybody else is doing it. Although we did put in the engineering time and effort to add a dedicated vector type earlier this year, plus ANN indexing and a whole load of cool features, some of which we'll have a chance to touch today and others in the future webinars in this series. So as far as the company is concerned, 100 million plus US dollars in annual recurring revenue and over 350 global customers. I think both those numbers need to be updated on this slide, but we can take care of that later. And then just down below, you can see some of the investors. Architecturally, this is a kind of a nice view, high-level view of the product and some of the capabilities. So universal storage, this ability to store both OLTP and OLAP, and work with both of those. So a variety of ways you can get data in. And if you plan to attend the event, I think we've got, there's a data engineering conference on Thursday where I'm actually going to be using pipelines, but that's one of the ways that we can get data in. You can see the animation here, okay? So if you're connecting from Kafka or Spark, or maybe just ingesting from S3 or Hadoop HDFS, that's a great way to get data in. We do run on the major cloud platforms in the Western world. Today, I am going to be using AWS because I am using the free shared tier, exactly as you would if you're going to sign up. You can run it on-prem. There's a Docker container as well, but the quickest and easiest way is simply to sign up and do everything in the cloud. Okay, there's nothing to install locally. Stored types, relational at its heart, lots of other things that we do support: geospatial, time series, key value, JSON, full text, and of course, vectors, okay, which is, oops, pardon me, trying to be too clever there. Vectors is the topic of today. And then just to wrap it up, some real-time decisions, AI apps, dashboards. So whatever is your favorite dashboard, Tableau or whatever, you know, there's connectors and JDBC, ODBC support as well. So let's move on. Okay, so let's talk a little bit about vector search then. So what is this whole thing about vectors? I mean, what's the, you know, why is there so much interest in this? Well, I guess ChatGPT is probably the biggest thing that has driven this, and LLMs in particular that subsequently emerged after that. So it's been a little bit of time now since all of this started. And as I tell the story, I mean, I ignored all of this for about 3-4 months. And then I finally thought, well, I better take a look at, see what all the fuss is about. And seriously, I mean, there's not really much to it. It is really trying to find ways that we might represent information. So it could be the written word, for example. And there's a famous phrase, you know, the quick brown fox jumps over the lazy dog, well known in Western literature. Or we could have an image, for example, of exactly that same information. Or perhaps there's an audio file that says something. In this particular case, there's no kind of indication that that's happening. It happens to say that particular phrase. And judging by the representation that we see on the right-hand side, you can see, in fact, that the values are somewhat different there. So essentially what we're trying to do is to take the information that we have and the representation that we as human beings kind of tend to understand and convert this into a form that a machine can work with. Hence the use of vectors here. And what are vectors? Just arrays of numbers. Okay, I mean, that's all it is ultimately. And it's about the efficient storage and retrieval and being able to run operations upon these. That is really the key to making and getting value out of this. And so really, you know, once we have this representation and either we decide to store it in a database management system, for example, in SingleStore, you can do that, or you might use, say, an in-memory library or something like that. The question then occurs, you know, well, how do we actually do something useful? So if we have some particular piece of information that we want to store, and then we want to query that, you know, what do we need to do to be able to get back some useful results from that? And here you can see this kind of nearest neighbor concept, which often occurs within retrieval augmented generation, semantic search, for example, face matching, object photo matching, and so on. And if you subscribe to or follow me on Medium, for example, just recently, let me just try and find the right tab. I think it might be this one. There's an associated article with that. I looked at Clip, which is this software from OpenAI, which you can get on GitHub. And I use this as a way to take a video, break that down into individual 1-second frames, store these frames in SingleStore, okay, by converting them to vectors, and then I can run queries on that. So I can ask, okay, you know, find me images that look like this, for example, and give it a matching image to search for. Or I can actually pose questions in text as well. So Clip is kind of pretty smart, okay? You can understand both of these. And that's a very useful application. Again, being able to query data and then ask questions of that. Now, my particular implementation isn't the world's best, but it works, okay? And that's the key thing. So there are things that you can do and useful things that you can do with these type of applications. And then, of course, there is this notion of, okay, let's say we have stored these vectors in the database. How do we determine whether things are similar or not? You know, if we're trying to look for patterns and matching these, you know, similarity searches, for example, what are the mechanisms that we can use? There's a variety of metrics that we can utilize, and the common ones that you'll see often in the literature and supported by various vendors, things like dot product, for example, you'll come across cosine similarity, Euclidean distance, and SingleStore out of the box supports dot product and Euclidean distance. Cosine similarity is not supported out of the box, but can be easily programmed. And if you have something that's more exotic, okay, there's a couple of others that are listed here. For example, Hamming distance. It's perfectly possible for you to write the code using WebAssembly and upload that as a UDF into SingleStore, and SingleStore will then run that for you and treat it as a user-defined function. So in theory, you can extend the capability of the engine ad infinitum. I think there was a customer not very long ago that actually did something similar to this. So that's a useful way to be able to add additional capabilities that the core engine doesn't support. Okay, now here's an example of one particular case. This is using something called FaceNet, okay, where we are looking for photographs of Emma Thompson. And so you've got these JPEG images, okay, which we are referencing here. So we've actually got the file name, okay, stored in this side here, and it's got an appropriate score. So some, this dot product operation has been used to be able to search and look for something that matches this. So we've got an image that we want to use, and we want to compare this against what's already stored in the database and return the score. The higher the score in this case, okay, the way that dot product tends to work, we can see these are ordered in terms of descending order. Well, the best match is at the first position there, okay? And indeed, if we take a look at this, we'll see that that is the closest match using vector similarities. So it has this very sort of, its uses. It can be very, very useful. And this is demonstrating images. Equally, it could be text. I showed you the example of clip just a moment ago in terms of taking videos, breaking those down into frames, for example, and running that. Many modern LLMs go one step further today. Recently, I think Google announced something that looks pretty awesome. So essentially, you just upload the video and you can ask questions of it directly. You pay them for the privilege, obviously. So, where do these vectors come from then? All right. So typically from large language models, okay, OpenAI, GPT-3, GPT-4, BERT, Claude, and you name it, many, many possibilities there. Sometimes from custom models, your internal AI or data science team may well generate them. In the case of the clip example, for example, I did not need to use an LLM. Okay, there's a series of packages that I use that actually generate the vectors for me, so I don't have to go outside of my environment in order to get these values. That's already done, and I simply store them in the database engine and then be able to query them. And then we saw an example of FaceNet. So it could be other things like neural nets, for example, that might be other sources. And one of the things that we are seeing, and I alluded to this just a few moments ago, is this concept of multimodal as opposed to multi-model. Okay, so SingleStore is multimodal. It can be multimodal as well. I mean, ultimately, it is going back to that diagram I showed you a few moments ago, where we have text, we have image, we have audio, we might have video, and the ability to store this kind of representation of that within the database engine, and then have some means to say, well, okay, this particular pattern of text is actually very similar to this particular image. Okay, you can do that with clip, for example. Okay, it can support both of these. Or, there is a particular sound, some audio happens to say the same phrase. That's very useful. Okay, so being able to query across these different data types, multimedia types, very, very useful. I think increasingly we're seeing these LLMs providing better and better support for this. Okay, so I think watch this space. And in case you're wondering, well, who on earth uses this stuff? And here you can see just some of the customers that we're able to share with you. Over 45 of our customers are using a variety of vectors in multiple applications. So everything there you can see ranging from finance to IoT. And I mean, some of these customers, I think there are case studies documented on our website as well. Okay, so you can read the details about what they're up to. In terms of indexing then, like I said, this is a very deep topic and something that we'll take up, I think, for a future webinar. We'll focus just on this and the different types of indexes and the kind of trade-offs between them, the circumstances that you might use them in. But the key thing here is that SingleStore supports all of these options. Let me just get my box here. All of these options today. What's shown in purple is what's currently recommended. Okay, so have no index. Okay, create an index. This is what's been in the product for some time. Exact match, 100% guaranteed to get you the right answer. And then, of course, this notion of approximate nearest neighbor. Okay, so we'll talk about that in just a moment. But there are others as well. This IVF PQS. Okay, so inverted files. I'm sure you've come across them. If you work with these kind of full text engines, and then this navigable small world. Okay, flat. So these are the kind of three main types that are recommended. We do support these others. There is an auto, which you'll see in the notebook that I'm currently using today, that defaults to this particular approach today, although they are adding more smarts within the technology to give you more options for that in the future. Essentially, I think the way it will work, and this is just my guess, okay, because I don't work for engineering, but I think the way it will work is that it will be able to choose the best index for you based upon the data and the distribution and so on, access patterns, and perhaps will be able to self-optimize as well, which would be awesome. And you come across this again in the literature, this approximate nearest neighbor. So the idea here is that when we've got large quantities of data, and here perhaps you're talking about hundreds of millions of data points, billions potentially, you need some mechanism to be able to search that. And this works really well over large vector sets, okay, where response time is critical. So you want to get fast answers. The downside is that because it's approximate, you're not guaranteed that the answers you get back are always going to be correct or 100% correct, okay? You don't need perfect recall. This is, I guess, for those kind of situations where it's acceptable to have a response, an answer returned back to you, where you want to make a quick decisions. Where it's critical, though, obviously, if you want to guarantee that absolutely everything that's being returned is the correct answer, then this wouldn't make sense. Okay, again, it's one of those business decisions. It's a trade-off. Sometimes one may have preference or priority over another, but this can work really well. And again, in the notebook, if you take a look, in just a few moments, we'll have a look at that. You'll see that even on fairly small data sets, ANN is exactly that. It's approximate. You don't get back everything correctly. And then it's a question of deciding, well, out of the number of elements or rows that I wanted returned, if it's 5, for example, and 2 of them are wrong, well, the accuracy is 60%. Yeah, you're only getting back 2/3 of the correct answers. So it's, again, one of those things you have to think about. Product quantization, a very useful technique. This is one of the things that can be, can assist in terms of creating these indexes. And this is a topic, again, you can go very deep into this. I'd strongly recommend, if you're interested in this, go to deeplearning.ai, take these 2 short courses, which are free from Hugging Face. Okay, so there's an awesome one on quantization fundamentals, and another one on quantization in depth. Okay, I took both of these courses. They are really, really useful. Gives you a lot of background detail and goes through detailed worked examples to show you what's actually happening under the covers and how this stuff actually works. Very, very useful indeed. And if you plan to use this or want to get a better angle and understanding of what's going on there. So think of this as lossy sort of vector compression. Okay, JPEG for vectors, as it's said here. It has many benefits, huge memory savings that you can get, great performance improvements as well, and minimal loss in fidelity and quality. So you're really getting a lot of benefit and not losing very much in return. And that can help you, especially if you want to, plan to use this over large quantities of data. Okay, and so with SingleStore, as I mentioned before, because we support these kind of 2 alternatives, certainly build time for the index could be a factor. So in this case, IVF is much better. The index size, much better as well, smaller. But in terms of search time and accuracy, then, HNSW comes out much better. Like I said, we'll cover this in more detail in the next webinar in this series. Okay, so we'll drill down into the depths of this. I'm conscious of time, so look, it's already 6:30. We haven't got onto the notebooks yet. But very briefly then, in terms of vector type, so previously SingleStore used to support this, which was blob. Okay, that's how you stored your vectors. So earlier this year, dedicated vector type here, and you specify the number of dimensions you want to store. By default, it's 32-bit floating point, okay? And you can store 64-bit floating point as well, or you can store integers of various levels as well. It's better, more readable, self-documenting, and has some benefits such as compile time error checking, for example. And if you've worked with SingleStore previously, you know that you had to go through this somewhat lengthy process of having to convert from this using this JSON array pack, JSON array unpack when you're working with blobs, and this just makes it a lot easier to work with vectors. There are some infix operators as well. So as I mentioned before, we support the dot product. Okay, so here's the infix for that. And if you're a Postgres user, these kind of infix operators should look very familiar to you. Okay, and for Euclidean distance, you have this kind of bar, and for dot product, you have the kind of asterisk there. Just shorthand notation rather than having to type those out in full. So we'll be using those today as well. Okay, and with that, let me switch over to my notebook, okay, which is this one here. So we'll work through this, okay? I've pre-run this, okay? You're very welcome, and hopefully once you've loaded it in, everything will be there for you to see as well. If not, I mean, it's very easy to just run the code. At the beginning, I've put some terminology, okay? A little bit of an explanation of dot product in layman's terms. As simple as I can make it, just simply because I wanted to understand it too. How do I explain it to somebody else? Euclidean distance and cosine similarity, okay? So as I said before, SingleStore supports the first 2 out of the box. The third one there, you can code it up in a bit of SQL code very easily if you want to utilize that. And then there's some concepts here that we'll use today as well. Principal component analysis and this TSNE. So the thing is, think about it. When we've got vectors, if it's kind of 2-dimensional, say you are measuring the length and width of something, and you can store those as numbers, that's fine. You can plot that on, a chart, a 2-dimensional chart. Even if you've got 3 dimensions, for example, yes, you can conceivably plot something in 3 dimensions. And as human beings, we can kind of understand that. Think about multiple dimensions, though. Previously in the slide, you just saw reference to 1536, which if you use OpenAI, these LLMs, is something that you'll be very familiar with in terms of numbers. 1536 is very hard for the mind to kind of comprehend. It's a huge number. How do we visualize something like that? How do we understand and see that? And it's the old saying, you know, a picture is worth 1,000 words. And sometimes it's very useful to have a way to visualize the data. And so what these techniques allow us to do is to represent that data effectively, shrink it down in a way that we can represent it in 2 dimensions. And visualize it. And you'll see, again, some graphs and charts a little bit later on where we actually do that with the data. So we start off just by installing some libraries. I typically run this at the beginning of everything now, hit cache purge, simply to clear stuff out. Sometimes these libraries tend to change, and it's good to just be sure that you are using the latest versions. Recently, I updated some notebooks for OpenAI and LangChain because the stuff is just changing all the time and very fast. You know, the libraries and the API constantly moving. It's a moving target, very, very hard to keep up as a developer. But you know, that's life. You know, you get great benefits from them as well, but you have to spend some time just knowing what changes in case it just breaks your code. We'll do matplotlib, scikit-learn, okay, and TensorFlow here. Just do these, okay. These will be very useful. A couple of these cells do take a little bit of time to run, okay. There's a fair bit that we're installing. And then we do all the imports here, okay. So we've set all this up. If you're using the free tier, which you should be, and I am as well, okay, you can see here that this is all I have currently running within my environment. So it's just the free tier. It essentially just does not need to create any databases here. But if you're using the standard tier, essentially it will just ensure that if these databases previously existed, they will be removed. So let's start with a super simple example, okay? And what we're going to do here is we're going to just take a couple of elements here, cat, dog, and car, okay? And we are going to associate some values with this, create an array, which, as you can see here, 2-dimensional, okay? So each of those has 2 values associated with it. And so we'll just simply plot this, okay, using a vector plot here. And you can see that, you know, visually this kind of helps us to see things a little bit better. Now, for 2 dimensions, this is fine, okay? Because we've only got 2 sets of numbers that we want to plot. But you can see straight away that, you know, with a lot of these vectors and the way that these LLMs and semantic search works is that things that tend to be closer together, like animals, for example, here, let me just see if I can draw around that, you know, are a lot closer together than something like a car, for example, which is pretty far apart from that. And the arrows just are there simply from the origin point, which is 0, 0 at the moment, okay? So at its simplest, I mean, this is the very basic mechanism that we have available in terms of plotting, very useful to be able to see these in a visual way. But as I said, things get a bit complicated after this. I mean, 2 dimensions is fine. I mean, we can comprehend that. Let's take something a little bit more meaty, okay? And then we'll look at a final example, which is even bigger. All right, so this is something that I use very often, the iris data set, simply because it's like a Swiss Army knife kind of thing. I mean, you can do lots of things with this data, and you can render it and you can manipulate it in many different ways. There's only 150 rows, 3 different species of flowers. And if you load this in here, you can see that we've got sort of 4 columns of data, okay? They are numeric. And we have 1 column which kind of describes what that actually represents, which species of flower that actually represents, okay? So this is just reading it in. Now, we can do lots of things with this data. It's very nice to be able to plot this and see this. And so here we're taking 2 sort of dimensions, okay? The sepal length, sepal width. And here you can see that that gives you a kind of visualization. So immediately, you know, without looking at the numbers, just looking at the plot itself, we can see that, well, one of these species of flowers is quite distinct, whereas the other 2, there seems to be a bit of an overlap between them there. And if you plot it using some of the other mechanisms available, you'll see a similar sort of pattern here. So that's very useful to know. Building machine learning models around this, sometimes you get misclassifications, and then kind of understanding why that might occur Here's one reason why that occurs is because there are similarities between these two species, for example. Another way, just a sort of simple violin plot here, and there's loads and loads of different ways you could do this. Okay, these are just two bare bones examples of how we could do this. Our next task is to say, well, okay, that is 4 separate columns of data. Why don't we combine this into a vector, a single column that represents those 4 values? And that is simply what we're doing here. Okay, so that's all this code does. We still keep our species column, okay, because that is, the, if you like, the label, and that's very useful. And once we do that, we get something here that's a little bit more useful. Okay, so you can see here that each row, okay, is now, we've got a column just to store a vector of those 4 values, and we've got a label, which is the species associated with that. And then once we've done this, something very useful that we can do is simply say, well, okay, I mean, we know this anyway because we've just built it, but suppose you were to do this using something larger, for example, it's helpful for the code to just tell you how many dimensions are you actually storing. So we're just querying this to determine the number of dimensions, which is actually 4. And here we're passing that value in to SingleStore here to create this table based upon the number of dimensions. And you remember just a moment ago, I told you that the default is 32-bit floating point, so I don't need to put that. It assumes that. We can store that data. And if we take a look at the description of the table itself, here it tells us that, yeah, it's 32-bit, and there's four dimensions to this particular column. Okay, so the next thing then is to say, okay, let's just write that data frame into this table, which is all we're doing there. And you can see the values here. It's 150 rows that have gone in. And then just as a kind of a sanity check, let's just pull some data back from the database, 5 rows that we can retrieve back and take a look and just be confident that, yes, these values have actually gone in. So this is what we're doing here, simply writing these out. And because of the way that SQL works, I haven't specified any order by or any other conditions upon that. Just pick me 5 rows and just return them to me just to check. And that's all that's happened there. Okay, great. Now, the power of this really comes in when we want to start to do interesting things. Now, at this small scale, obviously, it's a reasonably small problem. 150 rows is not very large, but even so, we might have something that we want to ask. We might say, okay, we have this data point here that looks like this. 5.9, 3, 5.1, 1.8, right? And we're kind of interested to know, does this point, where does this actually sit in terms of the 3 particular species of flowers, if at all? Equally, we might have a prediction that we want to make. So in the case of this first one, this highlight value, I've actually taken 1 row of the data. This is actually a row. I think it's the very last one in the data set. That is actually a real flower that's stored in the database. And then this one here, the prediction, these numbers I've made up. So I'm kind of curious to understand what it thinks is the species that this would belong to if I query that particular data set. So the first thing we'll do is with the first example that we know already exists, we're going to run this dot product operation. Okay. And again, you'll see that I'm using the infix notation there, okay, with the asterisk. And what it returns to me is that it tells me that this is the particular flower species it thinks that value is. And then we could do it the other way using the Euclidean distance, okay? And again, you can see the infix notation for that just below there. And because this Euclidean distance, essentially, it's like a straight line. I mean, it's finding the shortest path between one point and another. Given that row exists in the database already, the distance between that and what I'm trying to ask here should be 0. Because of the way that the data sometimes gets stored in the database, you want to be a little bit careful, okay? So hence the reason that I've added this to the end here, the 0.0001 rather than just 0 or 0.0. I've got away with that in the past, but there's no guarantee that that's always going to work, okay? You want to put something like that and use that instead, okay? Because, again, of the way that the database system may store floating point numbers internally, but essentially, we're looking for something that is identical. And again, if we query that and it returns us the result. So in this particular case, both these two methods of accessing that agree that this happens to be the particular species. And then going back to what we talked about, this way of representing the data in a visual form, which is very useful, we can do the plots both for PCA and TSNE. These are very straightforward, quite fast, because we're only dealing with fairly small data sets. So here you can see the principal component analysis, and our particular value is just down here, marked as such, under there, highlight, okay? So that tells you roughly where that sits. So that is, if we hover over that, it gives us a kind of some indication of where that actually is in terms of the species that it may be associated with. Okay, which, given the dot product and the Euclidean distance above, the Iris virginica seems to agree well with that. That's fine. And then similarly with the TSNE, we do that. And again, you can see that it's a very similar sort of plot. So one of these species you can see, again, very distinct, quite far away. The other two are a lot closer. And we can see that, yep, this happens to be in the same sort of general area as well, as far as this is concerned. Okay, so let's take the second value then, the one that we want to predict, the numbers that I kind of made up. And then let's see what the system, what the query comes back. So with this first one, then we'll say, okay, do the dot product, okay? And in this particular case, it tells me that it thinks it's Iris virginica. All right, so I'm doing a descend operator here because if you recall from the slides, higher is better as far as dot product is concerned. So that's what it thinks that. Now, it disagrees with my result for Euclidean distance, okay? Because here it thinks it's a different species. So the question arises, which one of these is correct then? So, all right, let me set that as a conundrum for you to think about. Both of these are actually correct, okay, in the sense that what we're trying to measure and the way that these actually work, all right? So there's no right or wrong answer, but in this particular case, we do happen to see that when we plot these here, you can see that actually that point, as far as PCA is concerned, happens to be Iris setosa, okay? It's where it kind of pops up. And then similarly down here with TSNE, same sort of thing, all right? Okay, so if we're looking at just, remember that K nearest neighbor diagram that we saw in the slides? Okay, so we've got a point and we're trying to find the nearest neighbors to that. So plotting it that way, we can determine that the closest best match, certainly as far as Euclidean distance is concerned, and what are the nearest neighbors, it would be Iris setosa. Okay, that's the species that we get back. Okay, so again, let me keep an eye on the time. Okay, let's move on to the slightly larger example. Okay, so this is taking the Zalando data set. This is really good, very useful. This is being used here under MIT license. So at the end of the notebook, you'll see I've acknowledged that, okay, because that's a requirement of using this data set. So we load the data set in. This consists of 60,000 images for training and 10,000 images for testing. Each of these images is 28 by 28. Okay, think of it as kind of pixels, if you like. We'll plot that in just a moment. And so if we pick the first item in the training, from the training images and have a look at it, this is what it looks like. Now, because of word wrap, that looks terrible. But you can see that the values range from 0 to 255. Okay, so it's 256. So these it's a kind of a grayscale. All right, we'll plot this in a moment. And so another way that we can see this, which is slightly better and gives us a kind of an indication of what this looks like, is as an image. So once we do that, if you look at this, that looks like a boot. Okay, so that is actually the representation of that. Okay, 28 by 28. Okay, and each of those points is a value between 0 and 255. And if we actually plot this properly, then, okay, this is what it actually looks like. Okay, ankle boot. And then subsequently, we can say, all right, let's take the first 10 items then, and then have a look at what those first 10 things are. And here you can see our ankle boot, okay, plus the other things, t-shirt top, dress. So there's 10 different types of items here, okay? So you can see some of them here. Not all of them are represented here. Just a little bit further up here, you can see here that we've got the means to specify what these actually represent, okay? These t-shirt, top, trouser, pullover, and so on, okay? So here, there's no need for us to create any vectors. If you think about it, look, we've actually got this already done for us, all right? It's a naturally occurring as part of the data set. So all we need to do is simply flatten that structure, okay? Convert the 28 by 28, and we can do that just below here, all right? And now what this does, if we take a look at the structure, it gives us 60,000 training images, okay, with 784 dimensions, okay, 28 by 28. And then the test images, same, 784 dimensions, okay? So again, just prepare the data frames, store these in that SingleStore, and we can take a look at the structure here. So there you can see the kind of the flattened vector, which is showing just the beginning there, the label that's associated with that item. And we can do that for both the test and the train set. Just convert those to string, okay, ready and prepare those to go into SingleStore. SingleStore will happily work with a variety of types in the vector type. So you can store things as NumPy arrays, for example, or convert them to 32-bit, okay, if you've taken the default, or you can even do it as kind of string as we're doing here. We'll happily accept those, but it is you need to excuse me, do your preparation there in terms of the data and decide how you want to get the data in. So again, we just create the two tables here. Okay, so again, we've picked up this number of dimensions from the variable just above. Again, save us time, because if we choose to change this, we only need to do it in one place. There's some other mechanism that we're using. All right, and again, we'll take a look at one of these tables. So again, it's given us that it's 784 dimensions, it's 32-bit floating point, and that's what's going to go in. Now, notice that these are not floating point numbers, okay? So they are integers, but that's fine, okay? All right, so we write the data frames. There's 60,000 records going into one table and 10,000 going into the other one. And then on top of this, for the training data, okay, our 60,000, we've created a vector index here as well to help us search this. All right, so with subsequent webinars that we'll do in this series, we'll pick something much larger than this. But this is great because it's reasonably sized just to show some of the results that you get when you're doing these kind of ANN queries. And in this particular case, you notice that I've taken auto as the option. Okay, so remember from the slides what that was equal to, plus the fact that the metric type I'm interested in is Euclidean distance here. Okay, dot product is the default if you don't specify it. One of the things that we can do then is just simply ask SingleStore, show me the indexes that you know about. And it says, well, I know about this. It's a vector index. If I scale to the right-hand side, it gives us the details that it's auto and it's Euclidean distance as well, okay? And there's this column store hash as well, which is created for you. So one way we can do this is to do the brute force sort of query. So we can say, okay, find me the closest matches, because this is Euclidean distance, okay? We are going to use the infix notation for that here. Pick an ID in that table, roughly halfway, Okay, 30,000. Now I happen to know that that happens to be a dress. All right, but again, you can change this yourselves. And then for the index, interestingly, the way that this is designed, this actually says do not use the index. Okay, use index, and you can see it's kind of blank. All right, so this is telling the system, ignore the ANN index, give me the brute force, go away and get me the exact match for this. And it does that. And obviously, the very first value that comes back is this one, where the score is 0, because that's the exact item that I am using to search. Okay, so it's matched it against itself. Okay, that's the best match available. And then subsequently, it's found the next kind of set of 4 closest matches based upon Euclidean distance. Okay, here, and those are just simply ordered in ascending order there, as you can see. And then what we can do then is to say, okay, let's find something that it doesn't know about in the test table. Okay, so find me something there, value 500, which again, I happen to know is a pullover. And again, using the infix notation. And we do the query. And so this is doing it across these 2 tables. Now, obviously, only one of them has the index. But again, we've told it, do not use the index. Do the brute force. Okay. And so in this particular case, again, we get back sort of 5 out of 5 in terms of the answer, as you can see. So that works great. Now, let's take this a step further and say, okay, for that first query that we just ran a few moments ago, this time use the index. All right. So over this fairly small data set, 60,000, again, if you compare the results here, it's identical to what we achieved previously. Okay, let me just get my box here. So all these numbers, unsurprisingly, okay, exact same thing there. It, match the dress against itself. It's the best match possible. That's why it's a score of 0. And then it found the next closest 4, which are all dress. That's fine. Here, though, this is where you start to see a little bit of this kind of ANN kind of kicking in. So again, we take the value 500, okay, which we know is a pullover from the query above. And it's using the index this time. And then notice here that only 3 out of the 5 results are actually correct, okay? So these 2 at the bottom, it's matched these as shirt. So we're getting 3 out of 5 here in terms of comparing it against the brute force approach. Now, for this fairly small data set, like I said, if you run and rerun this queries, you'll see variability in the result set. So if you try different values, you possibly may see 100% sometimes. It might be 80% sometimes. Here, for example, it's like 60%. I haven't seen it worse than that, but for this fairly small data set. Now, this is useful for me in the sense that if I wanted answers quickly over a large data set, yes, I could get those answers back quickly, but I may not necessarily get them 100% correct, okay, versus the brute force approach that we had. The brute force might take ages to run, and this is the benefit that the indexing gives us. Okay, now, finally then, PCA, have a look at this. There is our plot of 60,000 items there. And one of the nice things about Plotly, you can hover over this and you can see actually that there are colors hidden underneath as well. So there is a blue one, for example, ankle boot, although it tends to be mostly orange there. This is a good way to see it. But what I do like is this one, the TSNE, and the word of warning. This takes ages to render. So please be patient, go and make a cup of coffee or something, do something else and come back. It takes a bit of time to render this. And there you can see the distribution of the various types of articles of clothing, the ankle boot, the t-shirt, top, dress, pullover, shirt, and so on and so on. And there are areas that you can see there's an overlap. So this is helpful because, again, if you think about it, sometimes when you're building machine learning models and you're asking, running queries, for example, you don't get back an answer that's correct necessarily. It's because, something is is close enough in terms of matching, but is not exactly what you're looking for. This just helps to visualize that and see it in a nicer way, rather than just looking at a set of numbers. So there we go. Okay, and then just a little bit of cleanup at the end there. All right, just and again, if you want to keep the data, don't run the cleanup section at the end. Otherwise, you'll just have to rerun everything again. So as I said before, everything in this notebook is pretty fast, with the exception of this thing here, the TSNE. I have no idea why it takes so long. If you are a wizard at Python and you can fix my code or tell me what I'm doing wrong, how I can speed it up, by all means, drop me a message and I'll be very grateful and give you credit for that. But the rest of these are generally very fast. And again, for the queries themselves, take the time and opportunity to work with those. A couple of things that you can look at in the meantime as well. So as I said before, have a look at this clip, which does the video embeddings, okay? And that there's a technology that can handle both image and text queries, okay? Creates the vectors for you. And in case you're interested, we also did this recommender workshop very recently where we were looking at movie data, for example. And this has, like, I think, let me just see. There are actually 6 notebooks here, of which the first 4 are the important ones. The 5 and 6 are optional. But again, we're utilizing vectors. We're creating a machine learning model, generating the vectors, storing them in the database, then asking queries. For example, we have users who have a history of certain movies that they like. Now, we might want to be like a Netflix clone, for example, and offer our users some movies based upon the sorts of things they've seen in the past. What are the recommendations we could make for them in the future? So utilizing the vectors, utilizing these operations, the dot product, the Euclidean distance, again, to make these recommendations. And all of this is running in the database engine, okay? So this is the benefit. And the thing is that once you've generated these vectors and stored them, you don't have to do this again, okay? The model has been created, it's stored, unless you decide to change some parameters or reconfigure it or use a different approach. That is there permanently and can be queried again and again and again. Okay.
Well, just a small FYI, we are almost at the top of the hour.
Yep, thank you for that, Yukti. So 2 quick things that I was just going to mention is that the training.singlestore.com, there is a course on vector indexing as well. This is free, okay? You can register for that using ANN search in SingleStore. So that's a great kind of follow on from here. And then just let me wrap up here. Thank you for that. So summary, essentially, full power of SQL, transactions, parallelism, scale out. That's what you get with SingleStore. Vectors are queryable as soon as the transaction commits. In this case, we're dealing with fairly small quantities of data. Speed to match that of vector-only databases. We have a paper that my colleague Eric Hansen and I think his co-authors presented at VLDB in Guangzhou in China just very recently. And much faster than PG Vector, for example, Elasticsearch and similar sort of technologies. It can be as fast as pure vector databases. And with that, let me just go back here. I think we got time for a couple of questions. Sorry about that. Even skipping all the slides that I'd prepared and showing the notebook, we still end up exactly at time with virtually no time for questions. Sorry about that, but there we go.
That's all right. We can take up some questions, right? We actually have a lot of questions. So one question that actually popped up to me was like, someone wanted to know like very basic questions. Just give me a second to find it out.
Yeah, sure.
What's the basic of vector mathematics and their importance in data science? It's a very beginner question, but like just let me know.
Yeah, so I think, if you look at the literature, so keep in mind that statistics and a lot of the concepts behind machine learning have actually been around for a very long time. It's just, I think, more recently, because we have the power and the ability and the affordability, if I can put it that way, that with these cloud-based environments, literally you're paying pennies for the compute resources that you need to work with large quantities of data. all of these new sort of wonderful libraries have come along that allow us to do this kind of stuff on the data at scale, at speed, and get interesting results back out of it. The recommender workshop, for example, I'd highly suggest have a look at that, because that's a great way to see a practical example of where you could apply these concepts. So my suggestion is that deeplearning.ai is a great resource. Go there, take some or all of their free training courses. They will cover lots and lots of topics. Andrew Ng, for example, who's the founder, just recently he's offered a 4-course, on Python, beginner level, and he talks about some of the concepts that we've covered today, but he does it very much focused at an even simpler level than what I've been able to do today. That would be a great place to start.
So we have more questions like how
Yeah.
does the KNN search work over here?
Oh, yeah, KNN. Okay, so remember, KNN is brute force. There is no index used. Basically, it's doing a scan of all the data, the entire table. There is no index being utilized there. If you want the detailed how is it's implemented, I think that's something that we can follow up on. It's a little bit beyond the scope of today, but there is write-up detailed I think blog posts in the past that have been written about that, so we can certainly discuss that. But remember, think of KNN as exact match, okay? There is no ambiguity in terms of the result that's returned. ANN gives, that's why it's approximate nearest neighbor. ANN gives us the ability to access far larger quantities of data, but at what we lose is in terms of the accuracy. So what we gain, though, is the speed, but we lose the accuracy. And so it's a balance, a trade-off in business terms, what you feel is the best approach for you based on some particular circumstance or situation that you're in and the sort of queries that you want to run.
All right, so we have more questions. We have a lot of questions, like it's more than what we can take live. We're almost
Yeah,
like
just take a
so
couple
many
more, Yukti, if you
some of
can.
the
I
time.
think I know we're a little bit over time, but it's okay. We can get
Yeah,
through a
yeah,
couple more quickly.
absolutely. So if if you can go through, you can just pick out the questions that you feel like are the best.
Oh,
And I have one question though, like
yeah.
that I
Go
would
ahead.
take up. Just give me a second. So we have one question from Joydeep Bhattacharya. They say that is vector search supported on single store cluster in a box?
Cluster in a box? Yes, it is, because the SingleStore full product should be available. You can get the 4-node version and the license in the portal. That is the full product. The only limitation is the 4 nodes, and the cluster in a box should have the full product as well. I don't use that. I think in the early days when I first joined the company, I think I used it a little bit, but I switched to the cloud simply because they push out the updates on a regular basis. Everything is up to date. Cluster in the box, it takes, I think, a little bit of time for updates to get pushed out. It should be there, but I can't swear by it. I'll certainly take the opportunity to check it for you today and have a look, and we'll find out. And for my knowledge as well, but try it, but it should be there here.
Do you have any top use cases for top of your mind? So we have a question from Dan. They say that what are the top use cases for this particular this particular demo that you were showcasing?
Okay, so think about the Zalando example. We have on SingleStore, I think it's a e-store, SingleStore e-store demo, which actually takes items of clothing. So it's like one of these online stores where you can go in with a basket. You can sort of query and say, okay, I'm interested in jeans, blue color, this particular size, this particular style. Show me the list of everything that you've got. And so in that particular case, it can come back and utilizing the power of vectors, give you a kind of a response back very, very quickly. But I think that what I see the application of this is really wide ranging. I mean, there's so many uses that you can think of where this could be helpful. Commercial, finance, IoT. If you're storing data and you want to be able to look for matches at scale, at speed, I mean, this provides one way that you can do that. I think it's not the only option. If you think about it, there's always many ways to implement things, but certainly I think this a kind of array-like representation of the data, and the ability to then run these operations, dot product, Euclidean distance, looking for matches, looking for similarity searches. I think this has really come to the fore. And as I said a few moments ago, because of the power of LLMs today, they are increasing in power. The quality is getting better. The fidelity is getting better. The cost is going down all the time. It's pennies now to run stuff. And you can really benefit from this. And there's many problems that you could solve using these kind of representations of the data. And again, not just text-based, but videos, audio, images, and that gives you, immense power at your fingertips to be able to run queries across multiple types of data and get back results at lightning speed.
All right. So we are like almost 6 minutes over time. So
Okay,
we're
one more question.
Oh, right. All right. All right. Okay. Feel free to take them up. It's absolutely fine. Like I don't have a
Oh,
time.
no,
I don't
please
so
just
it's
pick
all
one.
right.
Just pick one. I mean, we'll follow up anyway, but
Yeah,
please.
absolutely.
Yeah,
So
yeah.
we actually have one question from uh Sean. They say that I see a lot of TensorFlow, but my understanding is falling out of favor. Curious to know why are we not using PyTorch instead?
Oh, yes, you can do. You're absolutely right. I think the industry is kind of moving towards PyTorch. By all means, whatever is your favorite package, whatever the favorite tools that you have, use them. I just happen to pick some particular technologies. In this particular case, because the Zalando dataset comes as part of something that TensorFlow, that's the reason for that. And if you check the libraries at the top and the imports that I've done, you'll see the statements there that show that. That was the reason for that. But yes, of course. I mean, if you prefer PyTorch, use that by all means.
So I have some question. Like I've seen this question like previously in some webinars as well. Like, is SingleStore like Google Colab, or maybe is SingleStore like a Jupyter notebook, which I feel like you can answer really well.
Yeah. So SingleStore, yes, that's a great question, Yuki. So yes, think of it as I guess you could. It's analogous to Colab. It is a Jupyter environment that we run within the portal. So previously we didn't have this. I mean, it's something that has been around for about a year and a bit, I think now. Previously it was in preview and it went GA. So this is something that's built into the portal and great for you as a data scientist, very useful because the environment is very forgiving. You make a mistake, it's okay. I mean, it tells you, there's an error in your code. You go back, you fix it. It's iterative development, right? And it's a nice way to be able to get results quickly. Now, will everyone use this? No, of course not. I mean, in many enterprise environments, for example, Java is still very, very popular, very widely used. So this can be very useful. I think I see this as a complementary technology for some problems. Sometimes people may use this as their main platform. That's okay. It just depends on what you're trying to solve. So yes, it's based on Jupyter. It's customized for our environment. And you have a lot of flexibility now, so you can choose between GPU, CPU as well. So that is there. If it's not there currently, you should be able to see it in the very near future. I think they're rolling it out gradually. And so, creating these containers, everything you saw me today, I didn't have to set this up. I just, import the notebook or create a new one, write my code, run it, and access the database directly as well, which makes my life easier as a developer because now everything can be done from the one platform.
All right. So we have one question from Kum Seong Moon. She says that could I get more detail about speed comparing to Elasticsearch?
Oh, yes. Yes, Yuxi. So what I'll do is there is a blog post we have, plus we can send some customer references as well. So that can be done as part of the follow-up email. So I'll gather those links together and send them to you, okay, after we close out this webinar today.
I hope that answers the question.
Yeah.
So
Yeah, we can send that out. Yeah. Are
um
you ready for the draw or you want to keep going?
I mean it's like I'm just looking for any questions that
Oh, okay. Go ahead. Yeah. So
I think
I think just to quickly say that yes, we'll go into more technical details in the next one whenever you decide to schedule that, perhaps next month
yeah.
maybe. we'll do a more detailed one just on indexing. Okay, so we'll focus just on indexing, and then another third one we can do that will do like the trade-offs between the different indexing techniques on large-scale data, and then tuning the indexes as well. I see those as sort of two next kind of steps, if you like, webinars in this series. This is just a kind of a primer, an introduction, and then we can take it sort of further in the future.
Right. So I think we can wrap this up as of now because we tried to take all the questions, but we're almost 10 minutes over time. So
Oh, yeah.
thanks
No
for
worries.
joining. And to the audience, if anyone has any topic ideas that you would like to see in future sessions, feel free to drop a message to me on LinkedIn. You can always like add, if you're trying to connect with me, just add it in your invite note. So uh, that will just like, no one will miss that then. So yeah. So speaking of future sessions, we have LLMs in fraud detection that we are presenting on September 13th this week. And um, actually, I just got a note for the September 20th webinar. This will be cancelled. So you can disregard
Oh,
this. Just
shame.
got a note. So yeah. So all right. So yeah, actually, I see a question regarding a Discord channel. Akmal, can you please put the link to the Discord channel in the chat if you can?
Oh, yeah. I don't have it to hand. Yukti. I think it's
Actually,
in.
you know what? Let's include it in the follow-up emails.
Yeah,
I
yeah.
can ask, I can
We
ask
can
someone from
include
the
that. Yes.
yeah.
Yeah.
All right. So
Um,
actually,
and
me and Pawan, we are managing that Discord channel, so I should be having it. Why don't I have it? All right.
yeah.
So um we will be announcing two winners by the end of the day for anyone that has tried out SingleStore notebooks during the session right now, and one person will be a random person that has attended the session. So basically the thing is that we have noticed that people click on the link afterwards the session, like it takes some hours for more people to click this particular link or maybe scan the QR code. So that is how we get, like, we can make it more fair that way. So stay tuned. You still have the chance to get entered to and be enrolled to win AirPods Pro or Meta's Ray-Ban LLM smart glasses. Simply click the link that's in the chat, and or you can scan the QR code, and we will be announcing the winner by email during the by the end of the day. And you can stay tuned for that. And if that would not be, you can always stay tuned for the next sessions. And thanks everyone for joining. This was a really interactive, very nice session. And thanks everyone for the amazing questions you got us. So thank you so much, Akmal, and have a great rest of the day, everyone. Thanks for joining. Bye bye.